This is lesson 0.3, but it's on page 135. On this one, we are graphing a line, but it's actually an inequality. And inequalities, we have greater than or equal to or less than or equal to and so on. That means you're going to end up shading part of the graph. Okay, a solution to a linear inequality is when an ordered pair makes a true statement. Okay, because if you think about it, if you have a graph and make this a different color, and it's shaded, any point in this shaded area will make a true statement. Okay, and we'll talk about this here more, but that's what they're saying. So on example 1, you have this equation, 4x plus 2y is greater than 6. And they want to know, is this point, does it make it a true or false statement? Would it be in the shaded area or not? How could we figure that out? Good, you have two options. You could graph it and see if that point's in the graph, or you could plug these values in and see if it makes a true or false statement. If it makes a true statement, it's in the shaded area. If it makes a false statement, it's not. Okay? So remember that ordered pairs go x and then y. So we would have 4 times 3 plus 2 times 2. And we are checking, we don't know, so I'm putting a question mark. Is it greater than 6? So what is 4 times 3? And 2 times 2 is 4. And when we add those, I get 16. Is 16 greater than 6? Yes, so this is true. It is a solution. So B, I'm going to go ahead and give you about 30 seconds. So go ahead and check to see if that one is true or false. You can write answers on your whiteboards, or 1 is true, 2 is false. You can show me with your fingers. Got it. Okay, good. All right. Most of you that gave me your answer said false, which is correct. So real quick, if I plug these numbers in, 4 times -1 plus 2 times 4, we're checking to see if it's greater than 6. We get -4 plus 8, which makes 4, and 4 is not equal to 6, which means my answer is false. Questions? All right, graphing inequalities. The first thing is the boundary line, okay? Determine whether it should be solid. So highlight this or box it. When you have less than or equal to, you are making a solid straight line. Where when you just have greater than or less than, this is a dashed or dotted line, okay? So remember how when we were just doing the line graphs, how it was solid, okay, for when it had the equal sign, where it was open if it wasn't. So it's the same kind of thing when you're doing these graphs. So this is a solid, and dotted represents the two different ways. You can test a point in the region to see if it makes a true or false statement, so you know which way to shade. So if you had a true statement, you would shade that side, okay? If you have a false statement, you would shade the opposite side. You also, if you're going to test a point, make sure the point is not on the line, because any point that's on the line is going to make a true statement, right? So you have to pick a point that's not on the line, that's like on one side or the other. I personally feel like it's easier to just shade based on what the answer says. So for me, like if I see less than or equal to or less than, you're going to shade down, okay? Because think about less than is smaller, less, down, where greater than you're going to shade up. So you just have to look at your line and decide which way is up and which way is down. And if that confuses you, then do the test point, okay? So example 2 here, we're going to graph. So we first need to go to y equals 3. So where is the 3 on the y-axis? Am I going to up or down 3? Or right or left? Sorry. Okay. Gave you too much information. Up 3. 1, 2, 3. And is my line going to go up and down or right and left? Right and left. And should this line be solid or dotted? Good. So we draw our line, and we're going to talk about this both ways. So we have y is less than 3. If I were to choose a test point, okay, 0 is usually the easiest test point as long as your line is not on it, okay? So if I were to choose 0, 0, okay, so if I'm doing my point method here, I'm going to choose the point 0, 0 and test it. If that is true, I'm going to shade down. If it's false, I'm going to shade on the side with 0, 0. If it's false, I'm going to shade on the opposite side. So if I plug 0 in here, I'm saying is 0 is less than or equal to 3. Is this a true or false statement? True. Since it's true, see how 0, 0 is right here? And it was true, that means the shading happens on the side where that point was. If this wasn't true, then that means the true part is up here. Now, if you go back here and think about this, y is less than or equal to 3. All the less than points are going to be down, okay? So if it says less than, you're going to shade down. Is that okay with everybody? Yes? All right. X is less than 3. Where is 3 on the x-axis? Right 3. And then will I go up and down or right and left? Up and down. Is this going to be a solid line or a dotted line? Okay, so this is dotted or dashed, however you want to say it and write it. If you made it solid, but you're like, oops, you can still make it look like it's dashed, right? Okay. Now, less than or equal to. Let's think about this. Less than, would I shade to the left or to the right? To the left. Good. So this is the only time when you're going to do left and right, but all the smaller numbers are to the left, aren't they? So that's how we shade. If we did the test point, again, I could choose the point 0, 0, right? If it's true, I shade on that side. So if I plug the point in 0, 0, that means for x, I would plug 0 in for x here. So 0 is less than 3, and it does make it true. So again, I should be shading on the side of where 0, 0 is. Questions before we move on? Okay. So now we actually have like a line with our slope. Do you think it's easiest to use slope-intercept form on this problem? Yes. Okay, so when we are drawing a line, we need 2 pieces of information. What 2 pieces of information do we need? Your y-intercept and your slope. Okay, so we have B and we have M. The y is completely by itself. What is my B value?
2.
Very good. And what is my slope? Good, -1/2. So where do I plot my first point? Very good, up 2 and make our point. From there, my slope is -1/2. So what direction am I going to go? Down 1, right 2. Perfect. And I can stop there. Or remember, if we had put the negative with the bottom number, I would have gone positive up 1 and then left 2 for the -2. Will this line be a solid or dashed? Okay, and we see greater than here. Which way do you think I would shade? So we're looking at our line. Am I going to shade above the line or below the line for greater? Above. So we shade above. Any questions on 3? Do you guys want me to do the point on this one? You want me to show you how the point works? Yes? So, okay, so again, is 0, 0 on my line? Right here? No. So I can choose 0, 0. So again, if I choose the point 0, 0, that means for x and y, wherever I see x and y in the equation, I'd be plugging in 0 for both of those. Okay? So that means I'd have 0 is greater than What's negative 1/2 times 0? 0 plus 2. So I have 0 is greater than 2. Does this make a true or a false statement? False. This is not true. So therefore, I'm not going to shade on the side of 0, 0 because it doesn't work. I shade on the opposite side. Okay? So false means you shade on the opposite side of from where that point is. All right, example 4. If you like shading here where you're like greater than means shade up and less than means shade down, you have to have this in slope-intercept form. If you keep it in standard form like this, you have to do a test point, because you know how when you move things around, sometimes you divide and you have to flip the inequality sign. So if y isn't by itself, you have to test a point or make it so that y is by itself. So do you guys want to do this in standard form, or do you want to go ahead and just change it to slope-intercept form? Okay, so we'll change it to slope-intercept form. So in order to change this to slope-intercept form, what will I do? Very good. Add 3x to both sides because we want to get the y by itself. Okay, when I do that, I get 2y is greater than or equal to, and I want this to be in slope-intercept form, so should I write 3x first or 6 first? 3x, good. And I can't add 3x and 6 together because they're not in the same family, right? They don't match. They have to match in order to add them together. This has an x, this doesn't. I cannot add them together. What is next? Divide by 2. Now remember that when you're dividing by 2, you have to divide it to every single term. When I do that, I end up with y. Am I going to have to flip this sign? No. Why not? Good. I divided by a positive. Very good. Is greater than or equal to 3 over 2x. So notice how I kind of pull the fraction out in front so it's easy to see the m value. Okay? And then plus, and 6 over 2 reduces to 3. Very good. All right, now what are the two pieces of information I need in order to graph a line? Good. Your b value and your m value. What is my b value for this problem? 3. What is my m value? Where do I go to plot? What do I plot first, and where do I go? Very good. And that represents my y-intercept. Very good. From this point now, we use our slope. So where will I go from this point now? Up 3, positive 3, right 2. Okay, remember that 2 negatives make a positive, so I could have also gone negative 3, negative 2. Will this be a solid or a dotted line? Solid. And if we look here at our inequality, that says greater than. So again, you have to kind of look at this. Do you think greater than is going to be up here or down here? Up. Very good. So that is where I would shade. Or again, you could do a test point if you wanted to. Do we have any questions? There's one thing I wanted to say. What happens if like your y-intercept was a fraction? Let's say the fraction is a half. Where would you go? You would just go up a half, right? You just like make a little point there. And then if your slope was 3 over 2, you just keep in the middle and go 1, 2, 3, and then write 2, and your point just stays in the middle, okay? So don't let fractions scare you when you're graphing.